Hi viewers, welcome to my channel. This is Sridhar Reddy Elpeddi, Assistant Professor of Physics from Government Degree College for Women, Nalgonda. Welcome to my channel, Sri Quantum Academy, Feel the Physics at Glance. Today I am going to discuss with you Basics of Electronics Part 2. In that I am going to discuss with you band theory of solids. Before going to watch my video, please subscribe my channel if you not yet done. Press bell icon to get latest updates. Please watch, share, like, comment my videos. First, the band theory of solids. According to band theory of solids, the energy levels of an atom in a solid are not exactly same as that of atoms in gases. That means the energy levels in a solid are entirely different from the energy levels of an isolated atom. This was the theory first proposed by the Felix Bloch. He given the idea using quantum theory about the energy bands, and after that Walter Heitler and Fritz London discovered the bands in a solid. Before going to explain the band theory, let us recap the previous knowledge about the energy levels. Generally, each material is made up of group of small entities. That smallest entity is called atom. So each material is made up of atoms. Depending on the interatomic distances between the atoms in a material, materials are divided into three types. That means depending on the distance between two atoms in a material, materials are classified into three types: gases, liquids and solids. Generally, gases means the interatomic distances between the particles is too large. So there is no interaction between the two atoms because they are very far away from each other. So there is no interaction between them. So the energy levels of an atom are not at all influenced by the other atoms. This is the situation in gases. Next, in liquids, the interatomic distances is moderate. That means it is not too large, it is not too small. That means there exists a weak interaction among the particles. So there is an interaction between the atoms, but it is too small. This is the case of liquid. Now when come to the picture of a solid, solid is made up of group of atoms which are closely packed. That means the interatomic distances between the atoms is too small. They are closely packed. So since one atom is completely packed by the nearest atoms and the interatomic distance is too small, so there is an interaction between the atoms. Now because of this interaction between the atoms, the energy levels of individual atoms are affected by the nearest atoms. That means since there is an interaction between two atoms, so there is an interaction between the energy levels of that atoms. So this atom energy levels are influenced by all other atoms in the material. So the energy levels of an atom in a solid are not look same as like that of gases, because in gases there is no interatomic interactions. So the energy levels of each atom individual, there is no influence of other atoms. But whereas in solids, the energy levels of each atom are influenced by the all other atoms. This is the basic idea to develop the band theory of solids. Let us consider sodium atom. Sodium atom electron configuration is 11. That means it contains 11 electrons which are revolving around the nucleus. The electron configuration of sodium is 1s2, 2s2, 2p6, 3s1. This means 1s energy level, 2s energy level, 2p energy level, 3s energy level. In that way, there are another energy levels which doesn't have any electrons. If you look at the orbital configuration, see here, this is the nucleus of sodium atom which contains 11 protons and 11 neutrons. Now around this nucleus there is a first orbital, that is 1s orbital, which has 2 electrons, 1s2. So these 2 electrons revolving around the nucleus in circular orbit. Now after this 1s there is another energy level, there is another orbital 2s. 2s orbital has 2 electrons, so these 2 electrons also revolving around the nucleus like this. After 2s another energy level 2p. The maximum electrons in p orbital are 6. Now 6 electrons are revolving around the nucleus in p orbital, so 2p6. Now after this there is another orbital, 3s orbital. Actually, the maximum electrons in s orbital is 2, but here there is only 1 electron because 11 electrons are there. In that, 2 are filled in 1s, 2 are filled in 2s, 6 filled in 2p. Now only left with 1 electron. That 1 electron is revolving around the nucleus in 3s orbital. This 1 electron which is revolving in outermost orbit, that means last orbit, is called valency electron. The orbit or the shell which is outermost to the nucleus is called valency shell. In the valency shell there is only 1 electron. And here important is valency shell means that is the shell which contains at least 1 electron, the highest shell which has electrons. So after 3s there is another orbital 3p also, but there are no electrons, so you cannot say 3p is also valency. Okay, valency means it should have at least 1 electron, and that should be the last shell, that is called valency shell. So now here 3s1 is valency shell and it has only 1 electron. According to Bohr theory, each orbital has a definite particular value of energy. That means each orbital has a specified value of energy. These energy states can be represented with sharp lines because they have a particular value. There is no change in the value. That's why, since they have a sharp energy value, in energy level diagram they can be represented with sharp lines. You can see here, this is the sodium atom and these are the energy levels on the energy level diagram. 1s orbital, 2s, 2p, 3s, these are the energies which are represented with sharp lines, right? This is valid only for an isolated atom. That means if there is no influence on this atom, then I can represent with sharp energy lines. Let us suppose if there is another atom which is nearer to this one, then there is an attraction between this atom and that atom. Then what happens? There is an attraction between their energy levels. So in this case I cannot represent energy levels like sharp lines. You can see here, these are the two atoms. Let us suppose there is only this atom, then these are the energy levels. Similarly, if there is only this atom, then these are the energy levels. But these two atoms are side by side. That means there is a small distance between these two atoms. Then there exists an interaction between these two atoms. This interaction exists among their energy levels also. Now, because of the interaction between energy levels, now these two energy levels merges, and now see here, 1s of both merged together and 1s has two lines. 2s also same, 2p, 3s, 3p. In this way, each sharp energy level now spread over the distance. It is the mixture of two lines. One is because of one atom and another is because of another atom. In this way, neighboring atoms' energy levels group together and forms thicker energy level instead of sharp line. Now it is not a sharp line, right? Similarly, let us suppose there are 4 atoms like this. Now all 1s orbitals of 4 atoms grouped together. Similarly, 2s orbitals grouped together, 3s, 2p. In this way, all the individual orbitals which have energies slightly different are grouped together and they forms thicker energy level. Now you cannot say they are sharp energy level. That sharp energy level concept no longer acceptable here. Now check the case of solid. Actually, in solid, large number of atoms bound together with closely packed manner. That means one atom is surrounded by many atoms and there is an interaction between this atom and another atoms. That means, so the energy levels of a single atom are influenced due to the all other atoms. Similarly, the 1s orbital of one atom are influenced by all other atoms. In this way, all the 1s orbitals which have slightly different energies merge together, group together, and they form 1s band. This is called band. Here band means it is the mixture of all the 1s orbitals of each atom. Similarly, 2s orbitals, all the 2s orbitals which are slightly different energies are grouped together and forms 2s band. In similarly 2p band, 3s band, 3p. In this way, up to valence shell only electrons are there, but after valence shell there are energy states which have no electrons. That means they are empty shells. Similarly, all the empty shells group put together and they forms empty bands. That means 3p, 3d. In this way, after 3s there are many other energy states which doesn't have any electrons. They also group put together and they forms empty bands because there are no electrons. In this way, bands are formed in solids. See here, if I consider sodium atom, 1s orbital is filled with 2 electrons. So now 1s band is filled with 2 electrons. Similarly, 2s band is filled with 2 electrons and 2p band is filled with 6 electrons. But 3s band, that is called valency band. Valency band means all the valency shells group put together and they forms valency band. That band has 1 electron. That means that is partially filled band. Now all the completely filled band 1s, 2s, 2p, they don't contribute for electrical conduction because they are fully filled and they strongly bonded with the nucleus. So they doesn't contribute for electrical conduction. So we don't bother about these filled band. So our interest is only partially filled valency band. Valency band has valency electrons or free electrons, and on the valency band there are empty states. All the empty states group put together and they formed empty bands. Now all these empty bands together called conduction band. Valence band and conduction band are separated by a small distance. That means there is a energy gap between valence band and conduction band. This gap is called band gap. Band gap means the energy difference between the valence band and conduction band. This gap is called band gap or forbidden gap. When electron jumps from valence band to the conduction band, then current starts flowing through the material. In generally, if you don't supply any energy to the electron in valence band, it never moves to the conduction because there is a gap. There is a forbidden gap. There is no energy state between the valence band and conduction band. So if you don't supply any energy, then the electron which is there in valence band never moves to conduction band. If electron is not moving, then there is no question of current. So only current starts flowing through the material when electron jumps from valence band to conduction band. But to do this one, you have to supply energy which is equal to the difference between valence band and conduction band. That means if you supply the energy equal to the band gap, then electron in valence band moves to conduction band. Now it leaves the valence band and it jumps into conduction band. This leads to electrical conduction. When electron jumps from valence band to conduction band accumulated with electrons and valency band suffers with deficiency of electron because one electron is jumping from valence band to conduction band. So in conduction band extra electron is there. Now in valence band there is a deficiency of electron. Before in valence band electron is there. Now there is a gap of electron, that is called deficiency of electron. Since material is neutral, when electron is jumping from valence band to conduction band, then for charge neutrality one minus is leaving that one, then what is left there? Plus. So that deficiency of electron acquires positive charge, that is called hole. Now valence band accumulated with holes and conduction band accumulated with electrons. In valence band one hole is there because one electron is jumped from valence band to conduction band. Now the nearest electron in the valence band can fill this hole. So what happens when electron jumps into this hole and electron get neutralized? Now same time the electron which is coming from another place, there it creates another hole. That means nearest electron is jumping into this hole. Now this hole is filled, but the electron where it is jumping, there it creates another hole. Similarly, in that hole another electron jumps. Now where it is jumping, there it creates another hole. దిస్ ఇస్ వెరీ సింపుల్ ఎగ్జాంపుల్. ఒక క్లాస్ రూమ్లో మీరందరూ కూర్చున్నారు, స్టూడెంట్స్ కూర్చున్నారు. ఒకరిని మనం అక్కడ నుంచి లేపి బయటికి పంపించామనుకోండి, ఇప్పుడు అక్కడ ఏమవుతుంది, ఒక డెఫిషియన్సీ వస్తుంది, అంటే ఒక గ్యాప్ వచ్చింది. ఇప్పుడు ఆ బెంచ్లో అక్కడ ఖాళీ ఉన్న దాంట్లో ఆ పక్కనున్న అమ్మాయి ఇంకెవరైనా వచ్చి కూర్చున్నారనుకోండి, ఇప్పుడు ఏమవుతుంది, ఇక్కడ ఎంటీ ఖాళీ అనేది ఫిల్ అవుతుంది. బట్ ఈ అమ్మాయి ఎక్కడి నుంచి వచ్చి కూర్చుందో అక్కడ ఏమవుతుంది, ఇంకొక ఖాళీ వస్తుంది. ఇప్పుడు ఆ ఖాళీలో ఇంకెవరో వెనక బెంచ్లో నుంచి వచ్చి కూర్చున్నారనుకో, ఇప్పుడు ఇక్కడ ఫిల్ అవుతుంది, కానీ వెనక బెంచ్లో మళ్ళీ ఒక ఖాళీ వస్తుంది. అంటే ఇక్కడ ఆ హోల్ అనేది, ఆ హోల్లో ఇంకొకరు వచ్చి ఫిల్ చేస్తున్నారు, ఇంకొకటి క్రియేట్ అవుతుంది. ఇక్కడ యాక్చువల్లీ మనకు ఎలా కనిపిస్తుంది, ఆ గ్యాప్ అనేదే వెళ్ళిపోతుంది అటు ఇటు అనుకుంటాం. బట్ అక్కడ గ్యాప్ వెళ్ళట్లే, ఆ గ్యాప్లో ఇంకొకరు ఫిల్ చేస్తున్నారు. ఈ ఫిల్ చేయడం వల్ల కొత్త గ్యాప్ వచ్చింది. సో మనకు అది ఎలా కనిపిస్తుంది అంటే గ్యాపే వెనక్కి మూవ్ అవుతుంది అనిపిస్తుంది. యాక్చువల్లీ గ్యాప్ మూవ్ అవ్వదు, ఆ గ్యాప్ని ఫిల్ చేస్తారు. సిమిలర్లీ వన్ హోల్ ఈజ్ దేర్, నౌ నియరెస్ట్ ఎలక్ట్రాన్ జంప్స్ ఇన్ టు దిస్ హోల్, నౌ దిస్ ఈజ్ న్యూట్రలైజ్డ్, నౌ దిస్ హోల్ ఈజ్ క్యాన్సల్డ్, బట్ that electron where it is coming, there it creates new hole. In this way, in valence band, hole starts moving from one place to other place. Actually here hole is not moving, but electron is jumping into this hole so that it is creating new hole. In this way, we feel that hole is moving in valence band and electrons are moving in conduction band. So the movement of electrons in conduction band and movement of holes in valence band both will contribute for the electrical current. In this way, semiconductors, electrons and holes both are contribute for the electrical current. So according to band theory of solids, the energy levels of an isolated atom are sharp lines. When that atom is in solid, due to the interaction among the atoms, the energy levels of individual atoms are grouped together, all the 1s orbitals grouped together and they forms 1s band. Similarly 2s, 2p, in this way all the energy levels grouped together and forms individual bands. In that, inner shells which are filled with electrons does not contribute for the conductivity. So all the bands which are filled does not contribute for electrical conduction, but the valency band contributes for the electric current. When electron from valence band jumps into the conduction band, then current starts flowing through the material. To jump electron from valence band to conduction band, you have to supply minimum energy which is equal to the band gap between the two bands. Band gap or forbidden gap means the energy difference between the valence band and conduction band. When energy is equal to the band gap is supplied to the electron, then it jumps from valence band to conduction band. When electron is leaving the valence band, it creates a deficiency of electron, that is called hole, which acquires positive charge. Now the hole in valence band, now holes are there in valence band and electrons are there in conduction band. In valence band, the electron which is nearer to the hole can fill this hole. When that electron jumps into this hole, hole and electron get neutralized and it creates another hole. Now that hole can be filled with another electron and now creates another hole. In this way, it looks like hole is moving but electrons are jumping into that hole. So in this way, in valence band holes are moving and in conduction band free electrons are moving. Due to the movement of electrons in conduction band and movement of holes in valence band, currents flows through the material. In semiconductors at absolute zero, no electron has enough energy to jump into conduction band from valence band. Conduction band is empty at absolute zero. Hence conduction band is empty, that means there are no electrons in conduction band, so there is no conductivity. So in case of semiconductors at absolute zero, semiconductor acts like a perfect insulator because there is no conductivity, because there is no electron jumps from valence band to conduction band. Depending on this energy gap between the valence band and conduction band, solids are three types. That means depending on the difference between valence band and conduction band, materials are divided into three types. First one, insulators. If the energy gap between the valence band and conduction band is too large so that no electron can jump from valence band to conduction band, hence there is no electric current. Such type of materials are called insulators. Insulators means in that materials the gap between valence band and conduction band is too far. So to send electron from valence band to conduction band, you have to supply more and more energy, which is not possible. Such type of materials are called insulators. The forbidden gap for insulators is about 5 electron volt. That means to send an electron from valence band to conduction band, you have to supply more than 5 electron volts. So according to band theory of solids, the materials which have valency band fully filled and the forbidden gap between the valence band and conduction band is too large are classified as insulators. Second one is conductor. If there is no energy gap between the valence band and conduction band, so that electron can make easily transitions from valence band to conduction band and contributes for the electric current. Such type of materials are called electrical conductors. That means there is no gap between valence band and conduction band, both are overlapped. That means the electron which is there in valence band, it is already there in conduction band. That means very easy to transfer from one to other because they are overlapped, there is no gap, so no need to supply energy. So according to band theory of solids, conductors are the materials which have the valency band partially filled and there is no gap between the valence band and conduction band. That means they are overlapped. Example for conductors are metals. Next one, semiconductors. If the energy gap between the valence band and conduction band is small and it is intermediate between the insulators and conductors, that means it is not so far as that of insulators and it is not overlapped like that of conductors, so it is moderate. If the energy gap between the valence band and conduction band is small, then that type of materials are called semiconductors. With small amount of energy, an electron can jump from valence band to conduction band and it contributes for electrical current. Such type of materials are called electrically semiconductors. Generally the forbidden gap for semiconductors is around 1 electron volt. Examples, silicon, the forbidden gap is 1.12 electron volts and germanium energy gap is 0.72 electron volts. That means if you supply 1 electron volt, then electron from valence band jumps into conduction band and it starts flowing through the material. So with the small amount of energy you can increase the conductivity. This type of materials are semiconductors. At room temperature, thermal energy is sufficient to send electron from valence band to conduction band and their conductivity increases as the temperature increases. This is about the classification of materials. If you see this diagram, you can easily understand that the energy gap between the valence band and conduction band is so long in case of insulators, and if you see the conductors, they are overlapped. That means there is no gap. So if there is electron in valence band, it is automatically in conduction band because they are overlapped. But if you see the semiconductors, it is not too long as that of insulators and it is not overlapped like that of conductors. It is moderate, around 1 electron volt. That means if you supply 1 electron volt, then electron jumps from valence band to conduction band in case of semiconductors. This is about classification of materials according to band theory of solids. Thank you. Please watch, share, like, comment my videos. Thank you.